This is Chapter 6, Section 2 Notes. Today we are going to be solving systems of equations, which are two or more equations at the same time, using substitution. So we're going to be plugging in. So we're going to review a couple of problems first. The review problem says, what is the solution? And they give you two equations, 4x plus 2y equals negative 32, and x equals 13. Well, because you have x by itself, x equals 13, I'm just going to plug it in to the first equation for that x. So I'm going to replace this x with the 13. Now, in order to do the replacement, I do have to make sure that I have parentheses around that 13. So what that's going to look like is 4 and then parentheses 13 plus 2y equals 32. Now it's just a simple problem of solving for y. So I have to do 4 times 13, which is 52. 52 plus 2y equals negative 32. Now I'm going to subtract 52 from both sides. And that'll get me 2y equals negative 84. And then I divide by 2 to get y to equal negative 42. So my final answer is y equals negative 42. And keep in mind that x equals 13 because it already told me that. So problem number 1 says, what is the solution of the system? Use substitution. So same type of idea. This is x plus y equals negative 32. And then it tells me x equals 3y. So I'm going to, because I have x by itself here, I'm going to plug in the 3y for the x in the first equation. Again, when I plug it in, I'm going to make sure I have parentheses around it. So that'll look like 3y plus y equals negative 32. Now the reason why I do this is because I replace the 3y with the x, and now I just have y's to worry about. So I can actually solve this equation for y. So 3y plus 1y will give me 4y's equals negative 32. And then I just need to divide each side by 4, and I get y to be negative 8. Now, I'm not done yet because I also need to know then, well, what is x? So I go back to this bottom equation that I used, and I say, okay, well, I now know y is negative 8, so I can just plug that in for the y in the equation. So I'll have x equals 3y, and instead of y, I'm going to say, okay, 3 times negative 8, because that's what y was. So I plug that in, and 3 times negative 8 is negative 24. So my solution is actually two numbers, y equals negative 8 and x equals negative 24. Problem number 2. What is the solution to this system? Use substitution. So I start with two problems here, two equations. Now they both don't have y equals or x equals. They have 3y plus 4x equals 14 and negative 2x plus y equals negative 3. Now notice how this y is the only one that doesn't have a number in front of it. That's actually a good thing. I'm going to want to get that y by itself, which means I have to move the negative 2x to the other side. So to do that, because it's negative, I do the opposite. So I'm going to add 2x to both sides. So then I get y equals negative 3 plus 2x. Y is by itself. The reason why I want y by itself is because then I can plug in this parenthesis in for the y in the first equation. So instead of 3y, I'll have 3 and then the parenthesis negative 3 plus 2x. Okay, so what that looks like is up here, 3 parenthesis negative 3 plus 2x plus 4x equals 14. So the last half of this equation stays the same. I just replaced this y, I took it out and put in what y equaled. So now I have to solve this. So I'm going to start by distributing the 3. So I will have negative 9 plus 6x plus 4x equals 14. And then combine my like terms. 6x plus 4x will give me 10x. So negative 9 plus 10x equals 14. Now I have to add 9 to both sides. and then I get 10x equals 23. Divide by 23, and I get x to equal 2.3. So that's great. I got my x, but now I need to figure out, well, what does y equal as a number? Not just as this negative 3 plus 2x, but what is the number for y if x equals 2.3? So I'm going to kind of make a whole loop, and I'm going to replace this x with 2.3. So I'll have y equals negative 3 plus 2 times 2.3. Now I can solve for y. So 2 times 2.3 is 4.6. So y equals negative 3 plus 4.6. So I get y equals 1.6. So again, two answers here. X equals 2.3 and y equals 1.6. Problem number 3. Systems with infinitely many or no solutions. So for part A, it gives us x equals, which is perfect. That's exactly what I need for substitution. Negative 2y plus 4, and then 3.5x plus 7y equals 14. So I'm going to take this x out and replace it with negative 2y plus 4. So when I do that, my equation now looks like 3.5 times negative 2y plus 4 plus 7y equals 14. My next step is to distribute. 3.5 gets distributed in. So I get negative 7y plus 14 plus 7y equals 14. So combining my y's, I have negative y plus 7y, and that just gives me 14 equals 14. Does 14 equal 14? Yes. So that means infinitely many solutions. That means any number that I plug in for x or y will work in this equation, or both of these equations actually, which is great. So then my next problem starts out with y equals 3x minus 11 and y minus 3x equals negative 13. I'm going to replace this y with 3x minus 11, so my equation will be 3x minus 11 minus 3x equals negative 13. So I can get rid of the parentheses because I don't have anything to distribute. And then I'm going to combine like terms. 3x minus 3x will be 0. So I get negative 11 equaling negative 13. This doesn't make sense. Okay, negative 13 does not equal negative 11. Not on any day. So this is going to be no solution. There is no combination of x's or y's that when you plug it in will work for both equations.